Hello, welcome to homework questions 94 through 98 in Chapter 1. Question 94 is a probability question, and you can read through it, but basically Augustine is looking to avoid one locker out of 535 lockers because it is haunted. So what is the probability that Augustine reaches in and pulls out that dreaded locker number 831 should he be worried? Well, there's only one locker he's worried about out of 535. So let's change that to a percent to get an idea as to his percent of probability in terms of getting that locker. So if we take 1 and divide it by 535, that gives us a decimal of 0.001, and we'll round to the 9. So he has less than 1% chance of pulling out that locker. So should he be worried? No, the probability is very small. So I said no, he should not be worried because he has less than a 0.2%. I said 1%, but he actually has even less than that. So very unlikely that he'll pick that locker. Question 95. Lourdes has created the following challenge for you. She has given you 3 of the 4 points necessary to determine a rectangle on a graph. She wants you to find the points that complete each of the rectangles below. As you go through and do this, I would strongly suggest you looking at the E tool on Desmos. That'll definitely help you identify that 4th point a little bit easier, and I'm going to kind of use that as I go through this as well. On part A, I do notice a couple things before I get started. The Y values of the 2 points are 2, and then we have X values that are the same at -1. So if I sketch the graph, and as I said, Desmos would already have this done for you, but -1, 3 would be here, -1, 2, and then 9, 2 would be right here. So then the other point has to be right here to make it a rectangle, which means that would be at 9 comma, because we know that one point right there was at 9, and then this one over here, that was -1, 3, so 3 would have to be your highest. So the 3rd point, or the 4th point on this one would be at 9, 3 to create that rectangle on the graph. If you move on to B, you got some similar stuff here. You have Y values that are the same, and you also have these X values that are the same. So if you get a sketch, 3, 7, somewhere up here, 5, 7, a little bit higher, 5, -3. Oh, sorry, wrong point. 5, 7 would be right here. Then 5, -3 down here. So therefore, to make it a rectangle, it's going to be down here, which is going to be at the, you go 3 places over. A little bit off there, about right there. So 3 places over, which would be at 3. And then we had to go 3 units down right there. So that point would be at 3, -3. On part C, this one's a little bit more challenging because it's not horizontal or vertical. -5, -5. So about right there, 1, 4. And then 4, 2. And so what I was thinking on this one is that if we could figure out what this change was, then we could do the same thing with this point on the other side. So if you go, what's this point right here? This is 1, 4. And this point is 4, 2. So you go down 2 and to the right 3. So down 2 and to the right 3. So if you did the same thing, if you went down 2 and to the right 3, that would be located at, to the right 3, -2, -7. And once again, from the point, what point is that? I was looking at the wrong one. From the point -5, -5, I went down 2, and that's where the negative 7 came from, and then to the right 3, and that's where the negative 2 came from. So to the right 3, I added 3, and down 2. And then on part D, we noticed that the 96s are the same, similar to A and B, and the 73s. So therefore, my fourth point on this one would need to be negative 52, comma, 1483. Find the area of the rectangles formed in parts A, B, and D from problems 95. So I went ahead and just pulled the dimensions from the previous problems, just looking at, once again, what these dimensions are based on the ordered pairs that we created, looking at the x's and the y's and the difference of them. And so I came up with this, which means the area of the rectangle in part A would be 10 units squared. B would be 20 units squared. And then D would be 208,680 units squared. Alright, on to question 97. Copy the diagrams below on graph paper, then find the result when each indicated transformation is performed. So the first one, A, reflect A across line L. So I'm just going to count. If I'm 2 units here, then I have to be 2 units here. So since they don't have the vertices labeled, let's plot the points. This point over here is 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. This one's 3 away, so it'd look like this. And that represents the reflection across the line L. So we'll just call this whole figure A prime. B, rotate figure B 90 degrees clockwise about point P. So we're taking this and rotating clockwise 90 degrees. So you might need some patty paper on this one. That'll be this side right here. That represents this side. I'm just kind of working my way around there. And that would represent your new figure rotated 90 degrees clockwise. Part C, reflect C across the line M. So I'm just going to take each of these points and reflect them across. And so that would be a reflection across the diagonal line. And then the last one, rotate figure D 180 degrees about point Q. So the rotation point is down here. So rotate that, once again, maybe using tracing paper. And there's part D for you, rotated at 180 degrees. And it doesn't matter clockwise or counterclockwise because they represent the same image. Question 98. At right is a diagram of a regular hexagon with center C. A polygon is regular if all sides are equal and all angles are equal. Copy the figure on your paper, then answer the questions below. Part A, draw the result of rotating the hexagon about its center 180 degrees. Explain what happens. So if we take this and we rotate it 180 degrees, these points are just going to change location to the other side, but then really nothing happens. The orientation of the hexagon does not change. So when this happens, this is what we call rotational symmetry. So when you rotate it and you end up back on the same figure. Part B, what is the result when the original hexagon is reflected across the line N? And that's here on the second figure down here. As shown at the right, a shape with this quality is said to have reflection symmetry. So if we reflect this, then this point becomes over here, and that point there, and so Once again, nothing really changes, and then this is called reflection symmetry. The line N is the line of symmetry of the hexagon. So once again, the orientation of the hexagon did not change in this case. And last part C. Does a regular hexagon have any other lines of symmetry? That is, are there any other lines you could fold across so that both halves of the hexagon will match up? Find as many as you can. So what would we have here? We could go across the opposite vertices here. Those would be lines of symmetry. So there's 3 of them. We could also split right through the middle of the side links. And that would be another 3. So it looks like we have a total of 6 lines of symmetry through opposite vertices and through the midpoints of the opposite sides.